All right, let's look at sum and difference for tangent. Sum and difference for tangent. Um, it's going to be, if you look at the formula, you have this pattern here where you're taking the tangent of angles A and B, you're adding them in the numerator. The denominator, you're taking 1 minus the tangents being multiplied. Now for sum, it's going to be addition over subtraction. For difference, it's going to be subtraction. It's the exact same thing, but it's subtraction over addition. So same formula, it's just sum you're doing add, subtract, and difference you're doing subtract, add. Okay, so let's go ahead and figure out the sum and difference of the following problems. It says find the exact value of the tangent of 75 degrees. That means we're not using a calculator when they say exact value. And we're going to use two angles from the unit circles whose difference is 75. So we just did this. We know that means that I'm looking for two angles. If I subtract them, it gives me 75 degrees. Now, as Miss Bennett said, when you see that 5 at the end, you know one of your angles is going to be 45. In this case, it's going to be my smaller angle because I need to subtract 45 from something and still end up with a big amount, 75. So I'm thinking of something bigger than 45. And that means that I just need to think about what 75 plus 45 is. We know if we add those two together, we would get 120. So I would have 120 minus 45. That would give me 75. All right, so let's go ahead and plug this out using the tangent formula. So I would have the tangent of 120 minus 45, and I'm just going to substitute into the equation for difference. And angle A is going to be 120, angle B is going to be 45. So I would have the tangent of 120 minus the tangent of 45. And I know in the denominator I'm going to be adding, so this would be 1 plus the tangent of 120 times the tangent of 45. From here, I'm going to substitute, and we know these values now. So I hope that you're not really having to refer back to your unit circle because we've seen these values quite a bit. I know that the reference angle for 120 is 60 degrees, so it's going to have the same tangent value as 60 degrees. Now, the only thing that's going to be different is that when I look at the cosine of it, it's going to be negative because 120 is in quadrant 2. So remember, tangent is taking the sine of that angle and dividing it by the cosine. So we know the sine of it is going to be radical 3 over 2. And if I divide it by the cosine, that's going to be a negative 1/2. And remember, I got to do the keep, change, flip thing. So I got radical 3 over 2 times 2. And those 2's would cancel. And so I know my tangent value for 120 is going to be radical 3. All right. So that's what I'm going to be plugging in. So I have the tangent of 120, or radical 3, minus the tangent of 45. Well, remember, that's that radical 2 over 2, radical 2 over 2 point. So that means that if I divide those 2 points to find the tangent, the sine and cosine values, it's going to be a 1 because they're the same. So the tangent of 45 is 1. And this is over 1 plus the tangent of 120, which we know is radical 3. And that is times a 1. So let's simplify this. If I simplify this, I would have radical 3 minus 1 over 1 plus radical 3. And at this moment, I have this strange radical expression in the denominator. It just looks all messy. So what I want to do is rationalize this, and this is taking you back to that Khan Academy activity that we did. But on Khan Academy, it taught you how to rationalize denominators. So what we're going to do is just multiply both numerator and denominator by the conjugate of this denominator. So I'm going to be multiplying both of these by 1 times radical 3. That way I can make this expression a lot neater, and I get rid of that radical in the denominator. Now remember, the middle terms cancel on the bottom. So really, I just got to square the first term and the last term when I'm multiplying the denominator's expression, right? So my denominator should end up as a 1. And when I take radical 3 times radical 3, that's just a 3. So in the denominator, I should have a 1 minus radical 3 because I got a positive radical 3 and a negative 1. In the numerator here, if we multiply these out, radical 3 times 1, that's just radical 3. Radical 3 times a negative radical 3 is negative radical 9, which we know is just 3. And then negative 1 times 1 is a negative 1. And negative 1 times radical 3 is positive radical 3. All right. So if I simplify this even further, I would have 2 radical 3's, right? So I'd have 2 radical 3. And then I know square root of 9 is just 3, right? So I got a minus 3 and a minus 1. That's just minus 4. And then this is over 1 minus 3. Well, that is a negative 2. So my answer here is 2 radical 3 minus 4 over 2. Okay, now I'm going to do the same thing, but this time I am going to be finding the exact value of the tangent of 165. I'm using 2 angles from the unit circle whose sum is 165. Again, I know because 165 ends in 5 that one of the angles has to be 45. And I just have to think, what would I add to 45 to get 165? And that, of course, is 120. So now I'm dealing with the same angles again. I am going to be taking the tangent, but this time I'm summing, so I'm using this formula of 120 plus 45. And I'm going to be using this formula, substituting for angle A 120 and angle B 45. Now remember, this is going to be a plus minus deal. So I will be taking the tangent of 120 plus the tangent of 45 over 1 minus the tangent of 120 times the tangent of 45. And what I'll get is, when I simplify this down, now mind you, we know these values because we just did it. The tangent of 120 we know is radical 3. We have plus 1, that's the tangent of 45, over 1 minus, and this would be radical 3 times 1. All right, so now we have for our expression equaling radical 3 plus 1 over 1 minus radical 3. And we want to get that radical out the denominator, which means we're going to multiply this expression by its conjugate again. And that means I'm going to multiply top and bottom times 1 plus radical 3. All right, just the conjugate of the denominator. And that's just to get that radical out the denominator. So our final answer would equal, on the bottom we would have, again, we just square the two terms because they're conjugates. So we would have a 1 minus 3. On the top, let's do the distribution. We would have a radical 3. We take a radical 3 times radical 3. And that would just be a radical 9. So that's 3. So we'd have plus 3. And then we'd have a 1 plus radical 3. So plus 1 plus radical 3. And I'm going to change the color so you can see it here. So our simplified answer in the numerator would be 2 radical 3 plus 4 over negative 2. All right, guys, we are going to move on from this, and then we're going to talk about verifying these identities.